Okay, class, welcome to TTV tutorial. Now we are going to handle empirical formula and molecular formula. And first of all, we are going to handle empirical formula. So let us go through empirical formula. Empirical formula. So, empirical formula in simple definition is the simplest whole number ratio of atoms of each element in a compound. So this is the simple definition for empirical formula. So it is the simplest whole number ratio of atoms of each element in a compound. So in this, we are going to see how we can get the empirical formula for different elements in compounds. So here, there are things that we consider while calculating empirical formula. First of all, when you are given mass, so that mass you first change it to moles. You get the moles of different elements. Then after getting the moles of different elements, then you get their simplest mole ratio, and then from there you get the empirical formula. So, for example, so in this question, you are given the grams of different components of hematite. So now you are asked to find the empirical formula of this compound. So in this, since you are given grams, let us say solution. You are given two different elements are inside hematite, or they are the ones that form hematite. We have oxygen and also we have iron. So you write iron, since contain 34.97 grams of iron. So the starting it is iron. So iron and 15.03 grams of oxygen. So oxygen is the second element. So these are the elements or the components of hematite. So now from there you can write their grams or their mass. So the mass of iron is 34.97 grams. Then for oxygen is 15.03 grams. So now since you have the mass, you convert this mass of iron to moles. Also the mass for these to moles. So from here now, here we have iron. Here we have iron. The mass or the molecular mass for iron. The molecular mass for iron, it is 55.85. So here you divide the mass, the given mass, which is 34.97 grams, divide the molecular formula 85 grams per mole. Then here we have the mass given for oxygen. Here we have 15.03 grams. So we know that the molar mass of oxygen is 16 grams per mole. Now you divide this and get the moles for this. So now here you can take your calculator. From there you divide this. It is 34.97 divided by 5585. On the iron, the moles for iron, it is 0.6261 moles. Then here, on the side of oxygen also you do the same. You will get 15.03 divided by 16. How many are you getting? Here you get 0.9393 moles. So now, after getting this, you divide the moles by the simplest mole number. So now here between 0.6261 and 0.9393. So which one is the smallest? So the smallest moles, it is 0.6261. So we are going to divide this with everything here. So here we divide 0.6261 moles. Then here also 0.6261 moles. So here we divide this and we get 1. So you divide this 0.9393 divided by 0.6261. So let's divide. Here I'm getting 1.5. So here this is the molar ratio. But now since it is 1.5, so we need to change this to become in a whole number form. Since this one now it is in decimal, so we multiply this with 2. So here we have iron. Iron is 1. Then we have oxygen 1, 5. So you combine the two elements, it is 1, then oxygen 1, 5. Now in atoms, there is no atoms that are always be this one 1.5. So we need to change this 1.5 decimal to whole number form, whereby we are going to multiply the whole of this by 2. So here we are going to multiply. Iron will be 2, then oxygen will be 3. So the empirical formula will be equals to iron oxide, iron 3 oxide, iron 3 oxide. So this is the empirical formula. This example 2 is different from the first example, since the components are in percentage form. So here we are first going to change this percentage to grams or to mass. So after changing the percentage to mass, then again you change the mass by getting the moles. Then from there you find the simplest mole ratio, the simplest mole ratio. So from here we can follow the procedures carefully. Solution. So now here we have here sodium, we have chromate, then also we have oxygen. So here we are going to write sodium. Since there are 3 elements, sodium, then chromate, then oxygen. So you first write the elements separately. So after writing this element like this, then you write now the percentage composition of each element. So from here we have sodium, which composed of 17.5%. Then we have also chromate, which is 39.7, 39.7%. Then also we have oxygen, which is 42.8%. Now after getting percentage like this, so you need to change the percentage to mass. So simply you just remove the percentage side, 17.5 grams, 39.7 grams, then 42.8 grams. Then after converting this to grams, now you need to get the moles for each. Okay, the mole for each. So now here we are going to get the mole. This one is 17.5 grams. The molar mass of this is 23 grams per mole. Then also here it is 39.7 grams out of 52 grams per mole. Then also oxygen here we have 42.8%. It is gram. Then also we have here 16 grams per mole. So after getting this, then now you can get the moles for this. So you can also use your calculator and we get the moles. It is 17.5 divided by 23, whereby we are getting 0.761 moles. Then let us also get for this 39.7 divided by 52.0. So here we are getting also 0.7633 moles. Also let us divide this. It is 42.8 divided by 16. So we are getting 2.675 moles. Now after getting the moles, you need to also simplify from the definition. From the definition here, it is the simplest whole number ratio of atoms. So we need to also get the ratio for all this. So from here now, we are going to get the simplest or the smallest moles here. So the smallest, it is this. It is 0.761. 0.761 moles. Also this one, 0.761 moles. Also this one, 0.761 moles. So you can divide this. This will give us 1. Then this 0.763 divided by 0.761. We are also getting 1. Then here it is 2.675 divided by 0.761, where we are getting 3.5. This and this. Also this and this. The reason also why we are not seeing units here, this is the ratio of two similar units. So all these units will be crossed out in the process of division. So now here we have sodium, which is 1. Then we have chromate, which is 1 also. Then we have also oxygen, which is 3.5. Then you write these elements together. Then oxygen 3.5. This one's 1. This one's 1. But now, oxygen is in decimal point. So we need to change this to a whole number. So here we are going to multiply everything here by 2. So when we multiply sodium, this with this, we are getting here sodium 2. Then here we are getting chromate 2. Then here oxygen, we are getting 7. So the